Hey guys, Absolute5 here again. So we are now going to actually continue where we left off with calculus, but this time everything we did up to this point was review. So now we're actually going to start the concept of calculus now, which is understanding what a limit is. So let's write off the definition first. So let's see. Def. Suppose f of x is defined when x is near the number a, then we write, use a different marker, we write the limit as x approaches a, f of x is equal to some value L if we can make the values of f of x arbitrarily close to L, but not equal to A. Now, so this is a lot to understand what the limit is. So it says, suppose we have a function, right? And that what this is saying is that we have this function and we're attempting to plug in a value or values that are close to whatever that we're plugging in into our machine, into our function. And it's going to spit out some value, L. L is, it could be anything. It could be a function, it could be a value, specifically an output, like we reviewed before. And that's why, remember, keyword is arbitrarily close. This is really important to understand, that you want to get close to it. You're not always going to plug it in and, oh, this is a problem. No, some functions actually work depending if you get really close to it, but not exactly close to it. It's kind of like getting close to the sun and not actually burning yourself, if that makes sense. So let's give an example of what this definition actually means. So we'll give a case where it does work and we plug it in, and then we'll give another case where it doesn't work if we plug it in. Plug in specifically the value, I mean. So this example here, the limit as x approaches 2 of x squared minus x plus 2 is, now before we give the value at the end, again, you read this as, again, the limit as x approaches 2 for our function x squared minus x plus 2 is going to give us some value, which we don't know yet. So let's plug that in. So remember, use parentheses when you plug in any value. So 2 squared is 4, minus times a positive is negative, plus 2. We can immediately see that if we combine these two, these cancel, and we're just left with 4. Now, this is a simple understanding that this is how, when you plug in for every value you see x, you plug in 2. That's the concept when you're plugging in the limit. Now, this was convenient that it worked. Now, let's see if I were to give you let's say if I gave you the limit as x approaches 1, x minus 1 all over x squared minus 1. If we remember with fractions, what can never happen in the denominator is if we have a 0 in the denominator. And now the question is asking you, the limit as x approaches 1, what's going to happen? Well, if you can't see it, we'll show you anyway. 1 minus 1 over 1 square minus 1. We're going to be left with 0 over 1 minus 1, which is still 0 over 0. 0 in the denominator, that's a no-go. That's never going to happen. It's going to be undefined. So because of this, let's take a value that's actually close to 1, or we can give a situation where if let's actually fix the problem a little bit. This can still go to 1, but we're going to add a little condition to it. That the value of x will be 2 if, let's see, so the first thing, if we have this, so this is the condition how it works. We're going to have the limit as x approaches, so let's have this situation. These are two conditions we're going to add to this function. So this function is going to work. X minus 1 over x squared minus 1 if x is not equal to 1. But if x is equal to 1, then the value will be 2. So meaning, if we have the situation of x goes to 1, then we're going to put in 2 everywhere we see this, and then we're going to get some value. So then, let's do both cases. So let's say if the limit as x approaches 0.5, which is, again, 1, this function will work. So I'll write it over here. Hopefully you guys can see that. Let's see, 0.5 parentheses minus 1 over 0.5 squared minus 1. You subtract these two, I get negative 0.5 on top. Then I get 0.25 minus 1, which would be negative 0.5 over negative 0.75. And let's see, what do we get from that? We get a positive value. Let's see, what is that? 0.75 divided by 0.5. We move the decimals over. We get to 75, 2. So it's 50 into 75, 0. Let's see, hold on. Can't go in this, we add a 0. Hold on. 75 goes into 50 0 times, we put a 0. So we had a 0 here. So 75 goes into 500. What is that? No, it's not 4 times, not 5 times. 6 times? Let's see, 75 times 6. 30, yeah. 6 times, so that's 450. And we're left with 50. The number repeated, so then this is going to be 0.6 bar, which is 0.6. So for a value that is not 1, this function actually works. And now the reason why we put this extra condition on it, so this way then this function will be able to work. So now let's see if we had the case of x equal 1, then this value is 2. So, okay, so all I did was on the side, I just divided negative 0.5 into 0.75, and I got a positive 0.6 as the value for this. Now, this makes sense visually, so let me actually draw what is actually happening with these two functions. So this new function that we made with that extra condition, so right over here. So this is still the graph of g of x when x minus 1 over x squared minus 1 if x is not equal to 1, and 2 if x is equal to 1. So visually it's going to look like this. The first function here is going to look something like this, but it's getting close. It's getting close to 1, and this is 0.5 that we chose in the beginning. Now, when we add the second condition to this, right? Now, when we add the second condition to this, we still have an open point at 1 because 1 will not work, but when we add the value 2, 1, 2, this is 1, this is 2, there's a dot here so that this function actually works. So that makes sense why we add a condition. That actually the function is still the same, it's just we add that little condition so this way it actually functions correctly. So this was a little confusing, I understand that. I apologize if I didn't make it clear enough, but we will have further examples of limits. We'll have more examples in the future so this way we can get better ideas of limits. But this is the idea of a little bit, this is just like the surface. We just scratched the surface a little bit of calculus. So I hope you guys enjoyed this lesson. This has been Absolute 5. If you enjoyed this video, like, share, and subscribe to my channel. And be sure to hit that bell button if you want to get more notification from me to really help me out. And that I always want you guys to remember that math is infinite because there are infinitely many possibilities.